This week we are looking at fractional exponents and how it relates to radicals. So the first thing I want to talk about is just the general rule of how you can write a radical as a fractional exponent. So if I had the radical, the nth root of x to the power of m, so the nth root of x to the power of m, I could rewrite that. And so it's equivalent to x to the power of the fraction m over n. So that is the general rule that we're going to be following. We can also write this rule flipped over the other way. So we could say if I have x to the power of m over n, I could write that as a radical. So that is equivalent to the nth root of x to the power of m. So both are the same expression, just flipped over on the equal sign. So first two problems we're going to do, we're going to write the expression in exponential form. So currently we have it in radical form. So it's in this form right here. We want to get it into exponential form. So we're going to be using that first box there. So number one, we have the fourth root of x. If you notice up here, it looks like I have a power on x, which is m. So I'm going to rewrite that so that there's a power. If there's no power written, you can write in x to the power of 1. So I have my expression like this. I'm going to label my n and my m value. So 4 is my n value, 1 is my m value. So now I'm just going to write it as a fractional, as an exponential form where I have x to the power of m divided by n. My m is 1, and it's divided by my n value of 4. So the fourth root of x is just equivalent to x to the power of 1/4. Number two, we have the cube root of x to the power of 4. So 3, that is my n value, 4, that is my m value. So my answer is going to be x to the power of m over n, 4 over 3. And these fractions can't be simplified any further, so you would just leave your answer exactly like that. The other kind of problem you're going to see is something like this, where we're given the expression in exponential form, but we want to put it into radical form. So that's when you would want to use this rule here, where you have it in exponential form, but you're trying to work back into radical form. So I do the same thing here. I just label my m value and my n values. M is always the numerator, n is always the denominator. And now I can write it in radical form. So I am taking the nth root, or the cube root, because that's my n value, of x to the power of m, which is 2. So the cube root of x squared. And then you would just want to look and see if it's possible to simplify your answer. So you would check that by writing this as the cube root of x times x, because it's squared, there's 2 of them. In order to take an x out, I would need 3, because my degree of my radical is 3. So I don't have 3 x's, so I can't take anything out, which means my answer is just the cube root of x squared. I can't simplify that. And number 4, let's take a look at that. We have m is 4, n is 3. So we are taking the cube root of x to the power of 4. And this is something that I can simplify, actually. So I'm going to rewrite this as the cube root of x times x times x times x. I have 4 of them. I have a cube root, so I need 3 of a kind. I have 3 x's right there. So I'm going to take out an x, and I'm left behind with the cube root of this leftover x. So that's where that one comes from. So my answer is x cube root of x. So that's generally how we use this rule for going from exponential to radical form. Let's take a look at how we would use this to simplify expressions. So here I have the 3 kinds of expressions we would see with rational exponents. So the first one, number 5, what we're doing is we're trying to evaluate this left-hand side to find the value of a in the equation in simplest form. So we're using exponent properties here, basically. For this problem, if you see 2 things being divided with exponents, If you remember, our rule for dividing exponents is that we subtract fractions, or subtract exponents. So in this case, I have x to the power of 5 over 4, and I'm subtracting 1/6, and it's still equal to x to the power of a. So in order to do this subtraction, I need to get a common denominator first. So I'm going to put them both over 12. So to get 4 over 12, I'm multiplying by 3, so that's 15/12. To get 6 over 12, I'm multiplying by 2, so that's going to be 2 over 12. And if I go ahead and subtract now, I get x to the power of 13 over 12 equals x to the power of a. And at this point, I can just say, okay, well, they both have the same base, 13 over 12 and a. I can just set those exponents equal now. So 13 over 12 is our a value that we were solving for. So that's all you do if you have a division problem like that. If you have a problem like this, where you have two bases being multiplied with exponents, what we do is we add those exponents. So this is the same thing as x to the power of 4 over 5 plus 5 over 4, still equal to x to the power of a. Same thing as in the last problem, I need to get my common denominator first. My common denominator for 5 and 4 is going to be 20. So I have x, I'm trying to get them both over 20. So to get 5 as 20, I'm multiplying by 4. So this is 16. To get 4 to 20, I'm multiplying by 5. So this is 25 equals x to the power of a. So if I add these two fractions together, this is x to the power of 41 over 20 equals x to the power of a. Sometimes you'll be able to simplify your fraction there. In this case, 41 over 20 does not simplify any further. So 41 over 20 is my a value. And the third type of problem you'll see is something like this, where you have a power to a power. So remember, the power rule of exponents is where you multiply these exponents together. So this is going to be x to the power of 2/3 times 5 over 6 equals x to the power of a. When you multiply two fractions, you just multiply straight across in the numerator and denominator. So 2 times 5 is 10, 3 times 6 is 18. So that's x to the power of 10 over 18 equals x to the power of a. And so I have 10 over 18 equals x to the a, or sorry, just equals a. So I just set my exponents equal to each other. However, 10 over 18, that can be simplified a little bit further. Those are each divisible by 2, so my answer is going to be 5 over 9 equals a. And that's all you have to do to solve.